do, I would like to introduce you to Larry Felker.
Hello. I'm Larry Felker. I'll give you my email address at the end of the presentation. It'll be on the last slide. And if anyone has any kinds of questions, shoot them to me, or I can give you my phone number and we can talk over the phone. So this is on control circuits, specific for fire and smoke dampers. And some of them get a little bit complicated for people who don't do controls all the time. So if I get enough questions, I'll set up something that explains more. Here are the things that I'm going to cover. We're going to start slow at the fire damper and smoke damper to make sure we got the basics down, but then we'll move along into a little bit more complicated wiring systems. Fire dampers. Now, fire dampers are not usually actuated, only the big ones are, because most are curtain dampers, but there are multi-blade fire dampers. Here we have an example. This is what the wiring looks like. So it's pretty straightforward. Over on the left, we've got hot power coming in. It goes into a bimetal thermodisc or click-on type of device. It's manual reset. And as long as the temperatures in the duct or damper are below 165 F, the actuator is powered and it drives the damper open. The 165 is pretty much standard in the industry for probably 90% of dampers, but now and then you see a 210 or 212. If you got a steam coil near a damper, you don't want to get nuisance trips. Now, smoke dampers. The smoke damper doesn't have any kind of temperature sensor. It's only going to respond to a smoke detector. So here's an example of a multi-section smoke damper. Here's an example of a actuator actually mounted to the axle of the damper. Smoke dampers can be mounted up to 2 foot out of the wall, so you don't have to have jack shafting, whereas fire dampers, the blades have to be in the plane of the wall, with a few exceptions. So a smoke damper, you might have a smoke detector mounted close to the damper, or you might have either a fire alarm panel or the smoke control panel with area smoke detectors that go ahead and sense the smoke, and then they would operate a local relay at the damper. And the wiring looks like this. The smoke detector relay might be mounted on the damper by the electrician, but there is no temperature sensor on the damper, and the smoke detector could be up to 5 feet away from the damper, but it's external from the damper. We could do normally open, normally closed, several different variations. So when anyone wants to, they can either via the arrangement of the contacts or by mounting the damper, the actuator open or closed, they can get any kind of sequence of operation for open or close that they want. Combination fire and smoke damper. By far and away, these are the most common. 85–90% of what's installed that's actuated is going to be a combination fire and smoke. So they're going to have a thermal sensor on them, the bimetal. They are almost always jack shafted. And the wiring is going to look like this. It's a combination of the other two wirings. The orange is the actuator. To the left of it, we have this bimetal. So we have our 165 limit, manual reset. And we have the smoke detector also. Smoke detection is typically externally mounted. Now and then they're mounted on the damper by the damper manufacturer, but that's not too common. And the connection to the fire alarm system is via the smoke detector or the smoke control system. It's not part of the actuator. So we've got two contacts in series with the actuator. We've got hot power over on the left. We go through a contact in the smoke detector, and as long as we don't have smoke, power continues available to the thermal sensor. And as long as we're below 165 F, we powered the actuator and it drives open. Now when we get to multiple actuators, here's an example of a multi-suction damper with two actuators on it. The wiring's just going to be parallel, so common gets run to both actuators. There's only one smoke relay and one heat responsive device, the 165F sensor, and they deliver power. As long as they're closed, power goes to both actuators and they drive open at the same time. Now there are re-openable dampers. Now we're starting to look at smoke control system, stuff that comes from Chapter 9 of the codes rather than Chapter 7. Over on the left, we've got a switch. It could be all digital and with a touch screen, or it could be an actual manual switch. But we've got an auto position at the top there, so hot power would be delivered to the auto contact. Then it would go to the smoke relay and then to the damper. This is a smoke damper. There's no thermal sensor. If that smoke detector is opened and there's a fire in the building, some event, the fire incident commander can flip that switch to whatever he wants. He can override it open, or he could turn it off. So if he needs to evacuate smoke, he might be opening it, or that might be helping to pressurize the zone. This is a re-openable combination fire and smoke damper. So here we do have a 165F thermodisc and a 250F. They're both manual reset. And in the auto mode, the smoke detector or that 165F could open up, and that would cut power to the actuator and it would spring closed. If the incident commander wants to override it, he flips the switch to hand or to override, whatever they've labeled it, and he sends power to the 250F thermodisc. So now the actuator would drive back open. If, however, the temperature at the damper rose to 250, the assumption is we've got hot smoke or flames actually starting to impinge on an area near the damper. We have to protect that wall, so that sensor opens and it can't be overridden any further. At that point, only manual reset would open it. The actuator springs the damper closed, and we've protected the wall or the space. Aux switches have been added in this picture. It's the same as the previous drawing, but now we're showing auxiliary switches on the actuator so that we can get position indication either to local light bulbs or LEDs, or more typically back to the firefighter's smoke control panel. I'll show that in a bit. And we have we show the extra contact on the smoke detector that would signal the fire alarm panel that smoke detector has opened up and that we have smoke in some zone. So that would set off a fire alarm. Let's look what those aux switches look like. Typically, the Belimos have two arrangements of aux switches on the fire smoke actuators. On the right, we show single pole double throw switches. It's rare that anyone ever needs single pole double throw, but we have them available in case some a little bit more erudite sequence of operation is called for. So there's a switch at 5 degree, the S1, 2, and 3. When the actuator starts driving open, that switch changes over from normally closed to the normally open contact. Then when the actuator is driven all the way open, and we do have adjustable ones, that top or the open contact will flip over, and we can give position indication with it. On the left is the most common kind of setup that we have. 2 switches, one at the open end, one at the closed end. We set them for about 10 degrees and about 85 degrees on most of the actuators, but there are some that are adjustable. We don't normally need adjustable. How the aux switches can be used. Sometimes you got local lights. Either you got a damper that's hard to get to and you need to know whether it's open or closed, or you simply want local position indication so that maintenance can see how a zone is doing, that everything's okay. So this is one way we see them used. More common, they're used as position indication. So over on the right side, we have 2 individual switches, one that indicates damper open, one that indicates damper closed. The damper open one will typically do a green light, the damper closed a red light, telling us that we have fire. However, the codes do have that issue a little bit reversed at times. As long as it's clear on the firefighter smoke control panel what green and red mean, everything's fine. I'm a fan of green is good, red means fire, but that's not always the case. And these are required on anything that's in Chapter 9 of the codes, the smoke control systems versus the containment that's in Chapter 7. And now we look at some of the things that are in smoke control systems. This is the full wiring for the typical hardwired re-openable combination damper. So the top wiring shows what we showed as the re-openable part with the firefighter smoke control panel selector switch, and they can bypass it if a primary sensor is open so that they can evacuate smoke or pressurize a zone as needed. But it's also required in the codes that if it's in an engineered smoke control system, we have the position indication switches back to the firefighter smoke control panel. So now from the left little panel, which would actually be a much bigger panel with multiple switches shown, the incident commander can see is the damper open or closed, is it functioning, and then he can override open or closed as necessary. Someone with a walkie-talkie is telling him what they need up in a building. This could also be used as a testing system. The green light's going to be on if the damper is open, and you could flip the switch to off after 15 or 30 seconds when the damper closes. The red light would go on. You now know the damper went closed. Then you could flip the switch back to auto or open and see that the green light goes back on after the actuator opens. This is a bigger architecture of a whole system. So on the far left, we've got a firefighter smoke control system graphics panel. It's got the open close lights. It's got the switches for open, auto, or closed. It's going to be fed by the smoke control system panel, which is connected to the smoke detectors, which is connected to the fire alarm panel. So you've got 2 control panels there. Then you've got network wiring out to the damper. So we have what's there in the middle of the page, smoke control system relay module. That's going to have 2 outputs on it, and digital outputs and 2 digital inputs. So the top 2 terminals are actually coming from relays that are internal to the module, and they're going to do the give power to the primary sensor or give an override to that secondary sensor. And then at the bottom we've got our status switches, and we can see that the damper is either open or closed, and it'll show up on the graphics panel. So these are the same as slides. The top one is slide 16 and the bottom one is slide 21 that shows those as details. Modulating actuators. This is a quarter damper. It would typically be installed in a wall with a grill in front of it for access. It's a fire. You can see the below the actuator, you can see the manual reset thermodisc. So it is a fire damper, but it can be controlled as a smoke damper or a combination. So now we get into some little more difficult wiring, and I have on my last slides some arrow diversions that show how power runs. But if we're looking at a modulating actuator, the fire smoke ones are just the same as the normal Belimo, AFB, MFT or SR actuators. So we have common power, hot power, and then we have a signal going into wire 3. And somewhere on the control panel or module, there will be a connection between common and 3 so that we have completed circuits. We're not going to go into that. So we have 1, 2, and 3 directly wired over to the actuator. I'm showing here one of our potentiometers. So you could turn the dial of the potentiometer and it'll output anywhere from 2 to 10 volts on wire 3. And the actuator will drive all the way open or can be closed back down. We're in a steady state doing modulating control. If an event occurs, the 2 relays there can override the functions. So we could open relay 2 at the top, we would cut power to the common, the actuator would spring closed. Or let that one be back closed, we could change over relay 1. If we change over relay 1, we remove power from wire 3 to the signal, from the controller to the signal, and we short hot power 2 to 3. That drives the actuator all the way open. I show here cutting power 3, even though it's going to the Belimo device that can't be hurt. If 3 is actually some DDC control panel, you don't want to put 24 volt power on 3 because you could blow that output or the fuse if there are any. So you've got to disconnect power from your controller before you short it to wire 3 of the Belimo. Can't hurt the actuator. It's 24 volts on signal 3. It's the same as 10 volts. And these are showed with network connections. Here's how the wiring works here. But the signal out is where we'll start at wire 3 on the left side. The red arrow shows that current is flowing in that direction. And it goes through that normally closed contact, goes into the signal. Electrons flow back over to common and back out through the manual reset thermodisc, through the smoke relay contact, back to common. And so that circuit's completed, and the signal output can be 2 to 10 and can control that actuator. But if we needed to override it all the way open, here's how it'll be set. Hot power from 2 now goes not only to wire 2 of the actuator, but it goes to 3 of the actuator. And we've cut keeping hot power from showing up on the signal output terminal over at the left. And the damper will drive 100% open. We could get to some more complicated drawings. Here would be a combination fire and smoke damper with thermal discs. You can see that some of the wiring can get a little bit tricky. And I've had to do ones like this with battery backup for certain applications. Sometimes it's going to be spring open. Sometimes we want to drive it closed. So, you know, if anyone needs any tricky drawings, they can always get a hold of me. That's it. I'm ready for questions.
All right, Larry, thank you so much for that presentation. We do have a bunch of questions that have been coming throughout the presentation. Just want to let you know that the webinar, for anyone who had joined us during the presentation or partway through the presentation, this webinar is recorded and will be posted to various websites regarding Belimo at a later time. And we do have a handout for you today. If you're interested in getting a copy of the slides, you can go ahead and open the handout section and download that PDF of the presentation. Last but finally not least, in order to ask questions, what you're going to need to do is open up that question box, type in your question. I will read them aloud to Larry, and he will answer them as best as possible. If we do not get a chance to get your question answered, please be advised that we will contact you directly. And of course, Larry has shared his email address. If you should think of something after the fact, you can contact Larry directly. All right, are you ready, Larry?
Yes, I am.
Okay, first question. Is it against code to break power to a fire damper, smoke damper, or fire damper to get it closed for HVAC isolation?
No.
That was a no. Okay, thank you. Next question. Which manufacturers provide the dual thermo sensors?
All of the damper manufacturers have them.
Okay. Would it be against some sort of common practice or code to have the BMS send open-close signals to the fire smoke control system for them to open-close the FSD for HVAC isolation? Parentheses, as long as there is no fire smoke condition present.
As long as the control panel itself is UL 864 UUKL listed, no problem at all. And most of the major controls companies have UL 864 listing, or they'll have a panel that they'll have two versions. Sometimes they have the normal HVAC one, then they'll have one that's also listed to UL 864.
Okay.
So yes, you can, as long as you're UL 864.
Okay, next question, comment. For actuator auxiliary switches, why is 5 or 10 degrees considered closed and 85 degrees considered open? Shouldn't they be set at 0 or 90 degrees?
The accuracy of the damper opening and closing can't be done down at 1 to 2 degrees. It's just mechanically too difficult. And actually the damper rotation is, some of them aren't even a full 90 degrees. But since the damper rotation is 90 degrees, we set them at, to indicate that we've gotten closed, but not so touchy that we're going to get false indication. It is an issue, and we can use our adjustable switch one for the top end. The cost of putting in adjustable auxiliary switches at both open and closed would be prohibitive in the marketplace. That's I don't consider this a good answer because I agree with our question. How do we know for sure that we really closed? And that's where both during acceptance testing and the first year required periodic testing says that at 1 year you're supposed to check all the dampers. And that's where we see that that damper is closed and that the position indication is accurate.
Okay, thank you very much. Next question, does Belimo have any fire-rated actuators or actuator accessories that can directly interface with BACnet or KNX protocol signals?
No, but we're looking at it.
When using the FSCS, is it code required to monitor both the open and closed position?
When using the what?
FSCS.
I think they're in smoke control panel, right? I'm sorry, read me the question again.
Absolutely. When using a FSCS, is it code required to monitor both open and closed positions?
Yes.
Okay.
For if it's in an engineered smoke control system, Chapter 9. However, that isn't mandatory in some cities. I've done fairly large jobs where an exception was granted. I prefer myself to see the lights, but so your local official can always grant an exception. But strictly speaking, from the codes, yep, open and closed.
Thank you. Is it possible to have a FSD close when power is on, open when
Yes.
receiving a signal from a T-stat or interlocked with a fan, and still meet code, i.e., like in a boiler room or generator room?
I'm not sure of all of the wiring there might be there, but yes, as long as you have that manual reset thermodisc, but you can have them operated from a thermostat until they are required to close because of an event.
Okay. Is a disconnect switch required by code for the actuators?
Not in the IBC, and the only state I know of that has that requirement is Nevada, and they don't enforce it. I'm not a fan of seeing a local disconnect. We're talking about 0.2 amps here, the very small current. It would be hard to start a fire with the power that's being sent to an actuator. And I don't like seeing the local switch because then somebody could walk up and hit it by mistake. But any local inspector could require it.
Okay.
But no, the code in general doesn't accept in Nevada, as far as I know, and I don't know every state's local codes.
Okay, so I have a couple more questions, so if you'd like to still stay with us, please feel free. Larry, on your slide wherein you injected 24 volts on terminal 3 of your actuator, will that damage the actuator as you will be giving 24 VAC instead of 2 to 10 VDC? Thanks.
No, it is a standard practice for Belimo. 24 volt AC is just like 12 volt DC in this case. Not a problem. We do it all the time. We've been doing it for 30 years.
Okay. What is the code or codes you are referencing for smoke control in buildings? Specifically, are there any specific codes for healthcare facilities for smoke control?
There are a lot of codes mentioning this and a number of standards. The primary code is, of course, the International Building Code. Then you've got the International Fire Code. They both reference NFPA 92, NFPA 80, and NFPA 105. So by reference, those become part of code. There is the Life Safety Code, and there are several hospital codes, and hospitals are highly regulated. And overall, they do the best job of checking their dampers and taking care of things. And horribly enough, I'm going to miss one test question here. I've forgotten what that, it's not OSHPD, which is California in the code. I'll have to go through the alphabet to remember what the basic healthcare organization is. There is no health code building code per se.
Okay, last couple of questions. Do Belimo actuators meet the requirement of NEC code section 430.32B2, 3, or 4?
I'd have to go look them up. We meet the plenum requirements. We've tested ourselves to UL 2043. If whoever sent that question could joggle me on which ones those are.
Okay, we can follow up.
I used to be a field electrician, so I've read that darn code so many times, but I don't remember the sections off the top of my head.
Okay, we'll follow up with this individual. And last question, I still have a bunch coming through. When would you use area smoke detectors, and when would you use duct smoke detectors to control smoke dampers?
Well, it's up to the fire protection and mechanical engineers. It's not sort of a damper issue, and I'm not a fire protection engineer, I'm mechanical. Any large building is going to tend to use area smoke detection. The codes also allow you to put an area smoke detector above a door, but duct smoke detectors are hard to access. Area smoke detectors are preferable as far as maintenance goes, but I can't answer the question in any categorical way.
Okay. Thank you, everyone who typed in those questions. Unfortunately, we are running out of time and will not be able to answer them, but I assure you Larry will reach out to you and provide you an answer to your question. As always, thank you so much for participating in our Belimo webinars. We do have one final webinar for the year, and that's going to be on the 15th of November, and it's going to be a sensor-centric webinar. So if you're interested in participating, you can sign up via our website. I'd like to thank you very much, Larry, today for being an excellent presenter and sharing your plethora of knowledge with us. And I want to wish everyone a fabulous day, and we'll see you at our next webinar. Thanks, everyone. Bye-bye.